explanation for the following. Although the hydrocarbon calcine has so far defied synthesis, but it has been estimated that it would have a dipole moment as large as 5.6 diopters. Now, this is the structure of calcine. It's made up of two rings separated by a double bond, a cyclopentadiene and a cyclopentane ring. Now, this structure can undergo delocalization like this, to give a negative 6 pi electrons, which gives it aromaticity from the Huckel's rule, and it leaves the cyclopentane ring with 2 pi electrons, and so there is aromaticity in both the rings, giving stability. And because of this charge separation, the dipole moment is very high. The measured dipole moment of 4-nitroaniline, 6.2 diopters, is larger than the value calculated using standard group dipoles, 5.2 diopters. So let us write the structure expanding the nitro groups and the amino group. That would be like this, and this can undergo resonance such that this pi electrons moves towards the oxygen, being more electronegative, and so you get a negative charge here, you have a positive charge here, and so this bond shifts here and this bond shifts here, giving us this structure. So due to this charge separation of two positive charges and two negative charges, the dipole moment is higher. Dipole moments of furan and parole are in the opposite directions. So we've drawn the structure of furan and parole to show the lone pair of electrons and the unshared pair of electrons. Now, let us look at the various interactions. The factors we want to consider are the sigma bond dipole between carbon and the heteroatom, the pi bond dipole between the pi electrons that are delocalized and the heteroatom, and the dipole moment associated with the unshared pair of electrons and the heteroatom. Okay, so let's analyze this. Let's consider sigma bond dipole between the carbon and the heteroatom. The dipole moment is going to be toward oxygen because oxygen is more electronegative. Again, for parole, the dipole moment is going to be toward nitrogen because nitrogen is more electronegative. But since oxygen is more electronegative than nitrogen, the sigma bond dipole between carbon and heteroatom will be greater in the case of oxygen than in the case of nitrogen. Now coming to the pi bond dipole between the pi electrons and the heteroatom, let's consider for furan. For furan, the pi bond interaction between the oxygen and the pi electrons would be in this direction, and this would be greater for nitrogen than for oxygen, because nitrogen is going to be more giving of electrons and participating in the delocalization than oxygen. Coming to the unshared pair of electron, in oxygen of furan as compared to the NH bond in parole, we see that the direction is opposite. So the unshared pair, it is here in this direction, and for the NH bond it is in this direction. So these two are opposite. So these factors account for the reversal in direction of the overall dipole moment.